Hi again, everybody. Chris Tisdale here. Thanks for joining me. In this presentation, I'm going to continue my series of videos on geometric construction. In particular, we're using a special tool that you can see behind me. It's called a circle arc template. And in conjunction with a straight edge, I'm making some videos about how this circle arc template can replace the compass in the learning and teaching of geometry. So I've done a few videos so far. Let me share my screen with you, my document camera. Actually, let me grab the tool here and I'll show you an example, okay? So let me just share my screen with you. So here is the tool. So this is the most important part that we're going to look at. This is going to help us to accurately and safely and easily draw circle arcs, and you can position it on a given point. So the center's on a particular point. And together we use it with a straight edge. Now, this tool is part of a bigger tool called a Mathemat, and it's got lots of shapes and markings and stuff. You don't need all the markings to do the constructions that I'm going to show you. So you can see in the background, I've got a sort of a naked version. All right, so let me show you how we can use the tool. So the problem I'm going to discuss with you today is an ancient one, and it involves constructing a perpendicular line segment to a point that's on a given line segment. So let me draw a picture and I'll step you through it. Okay, so let's say here is our line segment, and I'll label the endpoints A and B. And what I would like to do is to construct a line that's perpendicular to AB and passes through the point C. Now, the point C in this construction is contained in the line AB. Now, this is a very famous problem. It's been around for literally thousands of years. And one of the reasons that we're using this new tool is because compasses are hard to use. They're not very accurate with their drawings, and sometimes they're unsafe. So this tool, as part of a template, is much easier to use. It's much more accurate and it's much safer. So let me show you some of the moves here, and we can work our way through it. Okay, now I am going to center my circle arc template at the point C, and I'm going to draw an extended arc. All right. And you can see that this cuts our line segment AB twice. So we've essentially created two new points there, D and E. Let's label them. Okay. Now, because CE is a radius and CD is a radius, C is actually the midpoint of DE. Okay. All right, so what now? What I'm going to do is construct an equilateral triangle with base DE. Now, if you remember back to a previous video, we actually did exactly this. We were given some line segment and we used our circle arc template and straight edge to construct a equilateral triangle with a given base. Now, we don't want this base for our equilateral triangle. We want this base here. Okay, so let's do that. So let me grab brown. Okay, so how do I produce an equilateral triangle? Well, we just follow the steps that we looked at in the previous video. So what I'm going to do is I'm not going to draw a full arc here. what I would like to do is just get this circle arc with center E intersecting my, my previous arc. So this is a new point, say F and G when I do the other side. So let me do the other side and then I'll label them. Okay, so there's another arc. Okay, so let's call this F and call this one G. Okay, so I've created or constructed two new points. Great. So now let's choose purple. What I can do is from this point to this point, draw a ray, and from this point to this point, also draw a ray. And where those two rays intersect, that'll be the apex of my equilateral triangle. So let's do that. So I'll go up there, and then I'll repeat the process over here. You can see they're going to touch at this new point. Let's call it I. All right, very last step. We've got a new point I. Let's form a line segment IC. I'll do that one in, let's say, I'll try green. Let's see what that looks like. All right, so using the straight edge, we can move that in there. And there we go. Okay, so this green line segment IC is perpendicular to AB and it goes through the point C. Okay, so let's just summarize what we did there. Okay, so we wanted to construct perpendicular to the given line segment AB, and it contains the point C, and C is in or on AB. That's essentially what we've done. All right, so let me just highlight that. Okay, so a little bit of justification now. How do I know that this really is a perpendicular to AB? Well, the idea is to show that this angle and this angle are equal. If that's the case, then they're both right angles, right? So a couple of extra parts that I'll just draw in just to help us understand the justification here. I'll draw in this line segment here, and I'll draw in this line segment here. Okay, so both of these little triangles are equilateral triangles because the three sides are all one radius. And because we're using the same radius, it's a fixed radius. Whenever I talk about radii or two radii, it's always the same length. Okay, so this first triangle, this triangle that we constructed earlier is equilateral. Now, if you haven't seen the earlier video, how would you justify that? Well, this triangle is similar to the bigger triangle, and that's an equilateral triangle. All right, so we constructed the equilateral triangle let's say it's triangle DIE. Okay. Now, you can justify that by just comparing this triangle with the larger triangle and use similar triangles. That's not really the point of this video. But to justify that this line segment IC is perpendicular to DE, well, that's pretty easy. You can just compare this triangle with this triangle, okay? So just to finish off this, this is the essential justification if you haven't seen the other video. So CGE is triangle similar to this, right? So what does that mean? It means that this side is equal to this side in length and this side in length, all right? So this triangle, this length is equal to this length is shared, and this length is equal to this length. So by side, triangle DIC is congruent to triangle EIC. Okay, because this length is equal to this length is shared, and this length is equal to this length because they're both radii. Okay, so what does that mean? Well, let me just move that up, sorry. The corresponding angles are equal. So this angle DCI has got to equal the angle ECI. All right, so in particular, this angle here has got to equal this angle here. So angle DCI, maybe I'll just put the tops on all those I's to make it clearer, is equal to angle ECI. All right. So what does that mean? It means, well, if that angle is equal to that angle, and they're both contained in the same line, they've both got to be right angles. That's it. Okay, so that's the challenge, the construction with our circle arc template and our straight edge, and the justification. Now, you can do this construction many, many different ways. I've probably seen 4 or 5 different ways of doing it, but none like this. None exactly like this. So maybe, I doubt if this is a new idea, but I found it really interesting. So let me know what you think. Have you ever used a compass? Have you had the same challenges, the accuracy, safety, and difficulty? Love to hear your thoughts. Thank you for joining me, and join me for my next video on geometric constructions using a circle arc template and a straight edge. Bye everyone. See you.